Uh, Hello, everybody. I'm somewhat surprised to see so many faces here, especially because this is the third day of the conference. My name is Adenilson Cavalcanti. You guys can just call me Ade. I think it's easier to pronounce, isn't it? Yeah. Okay. We're going to talk about plasma animation classes, which are going to be featured into KDE 4.4 release. In the first part of this presentation, I'm going to explain the origins of those classes. And the second part of the presentation, I'm going to go, I'm planning to have like a more deeper look into this subject. Okay. So the first question is why? Why should we care about those animation classes? And the answer is that it aligns perfectly with the Plasma objectives of having an organic feeling, of having a really polished desktop. As a matter of fact, KDE, since KDE 4.0, a set of animation classes were designed and integrated into the desktop. Second reason is that with Qt 4.6 we have something called Kinetic, which makes possible to create applications as also in both mobile and on desktop environments with rich content, with rich animations. And finally, because it was there was a directory, a branch on trunk, where a Turkish student started to work with the subject of porting the KDE 4.3 animation class to the new Qt 4.6. And since no one was working with that, I and my teammate Igor Trindade, we decided to take this challenge. Okay, so how it all started? Around August of last year, we implemented a proof of concept contacts plasmoid. And if anyone here is actually following Plasma Devel mailing list? Yeah, you don't count. Yeah. Okay, so what we got in 1 month of work was Kinetic Scrolling list, which is, I think it's one of really interesting features to have in a list, being actually able to have a kinetic feeling when you are flowing through the items on the list. We have drop shadows around the photographs on the contact. We got stacked rotations. I'm going to show stacked rotation running. And as also the more common effects like zoom, fade in, fade out, and finally the pulse effect. The pulse effect is that effect that you have when, say, in OS X, you have Finder, and double click in an application, and then you have like a pulsing icon to represent that the application is being started. Okay, I'm not able to execute this proof of concept anymore because since August, Kinetic API has changed. As a result, the code will not compile anymore. And since all those features were implemented in just 1 month of work, I can say that the code is not exactly pretty. So I have here a really low quality video that's going to just show how the proof of concept contacts work. Okay, so we have Plasmoid Viewer. We have the proof of concept contacts Plasmoid. And it's possible to see the kinetic scrolling list in a few seconds. I think it's been quite a long time since I did this video. Oh yeah, kinetic scrolling. Sweet, isn't it? We also have I think next we're going to see the pulse animation together with fade in, fade out, and the slide. Yeah. The pulse plus fade in, fade out, and pulse again and slide. Okay. Let's move to the next slide. Okay, so plasma animations are, at this moment, done after 4 months of hard work. On KDE libs, we have 108 commits only on this set of classes, plus at least 200 other offline commits in local Git repositories. Which, by the way, I think it would be just great if KDE ever decides to move to Git, because all those 200 commits done by me and my friend Igor, they represent the history of the code, but they are lost because it's only available on my computer. Okay, it went through 4 or 5 refactorings to get to the final shape. And we have 5 contributors. Maki Manaup, which was the Turkish guy who got it started, but it's been, I think, almost 6 months that he has no longer time to help on this effort. We have our friend here, Marco, who helped us to improve the design as also the code and fixed some bugs. We have Aaron Sagel, which is the alpha and omega KDE guy, which helped us to improve the design immensely. And finally, we have Igor, who unfortunately we are unable to get his visa to travel to USA. Blame USA government. And yeah, we have Ada Silva, also known as Ade, also known as Savago, which is, well, it's me. Okay, let's continue. So with this the ends, well, I'm going to vacations, finally. I'm going to have a whole month free to actually enjoy some things that we have like in Brazil, like outstanding beaches, exotic animals, also scuba diving, unbelievably placed pools, as also Rio de Janeiro, Carnaval Samba, and all this really outstanding stuff. But I realized that there is a really great locations in Amazon to visit too. Oh, that girl is my wife. But I realized that I still have like 22 minutes left. But this is why I have a second part. Okay. Now finally we are going to see some running demos. Let's move on. Okay, what are those Plasma Animation classes? They are specializations of Q abstract animation, which means that you can easily integrate it with more standard Qt animation classes like Q property animation. Has anyone here tried to write anything using Qt Kinetic before? Anyone? Yeah, but you know, do you remember Q property animation? Yeah, so basically you can just intermix Q property animation objects together with Plasma objects. So why we decide to go on this road? Mainly because it provides easier integration with Qt and user-created custom animations. Also because it helps to improve consistency on the whole desktop, have a common set of animations. And finally, because we can provide some more fancier animations for our users. And when I mean users, I mean not only end users, but also people that are actually using KDE libs to write applications. So, okay, demo time, finally. So, okay, what we have here is a plasmoid. I'm going to close this guy. It is on KDE examples, and it pretty much features the current animations that we have ready to be used. So we have pulse animation, grow animation, fade animation, zoom animation, slide animation, and rotation animation, stacked rotation. Try to say that twice as fast. If I click here on this button, all the animations are going to run. And this is the stacked rotation. Cool, isn't it? But I think maybe it's easier to actually see the animations if I run this guy. Okay. Since this is not running it's not running no longer as a Plasma module, we don't have the fancy background and the decorations, but it makes easier to actually see it animation running. The difference between grow and zoom is that zoom uses scale, so it's going to run faster, but it's somewhat dirtier. And grow actually transforms the geometry of the object. Fade operates on the opacity property of your QGraphics widget. Slide, you can set the direction. You can set the amount of pixels to move. You can also set different easing curves for each animation. And rotation is a 2D classic rotation. You provide the angle, you provide the duration of the animation, and that is it. Okay. I think what is really important is to see that using Plasma animations, you can both scale up, running on the desktop, as also you can scale down, running on embedded device. So the booklet has an Atom processor, 1.6 gigahertz. The Nokia 5800 has an ARM processor. I think it's a 360 megahertz. And the Nokia N97 is a 430 megahertz CPU. So we wrote and designed the code to be both scalable and to run fast. How to use it? And well, I got to say that it's just dirt easy. We have the following design. We have a factory pattern. If you guys don't know what a factory pattern is, you should read the Gangle for pattern design. I think it's design patterns book, which is, I consider it's like a holy Bible of patterns. You have to set the target widget. So say that you have a button. You have to say, oh, I want to animate this button. You have to set the parameters. So that depends on the animation that you are actually using. So if you're, for example, are using rotation, you have to set the angle and the direction. If you are, for example, using the pulse animation, you only need to set the duration. You can also use a different using Q-easing curve, and so on. And finally, you just call start. Well, this is the moment where if we have designers or non-coders together with us, they start to scream, because I'm going to show source code. And I promise that from now, things are going to be way more harder. Okay, this is the code. I think on this side it's easier to see. So you have to actually include the animations header file. You create an animation object using the create method on the Animator Plasma class, providing the type of the animation that you will actually want to use. Then you set the target widget, say a button. And if you want, for example, when the button is clicked to call the animation, you have to connect the signal slot with the signal the clicked signal with the start slot of the animation. And that is it. What is the level of integration with Qt? Well, integration is just you have to have an animation group. You can just call add animation. So there's no difference between Plasma Animations and Qt property animation. How to port from Plasma Animator to the new class? Actually, that depends on what you have been using Plasma Animator for. So I will give you an example. Oh, source code again. Oh, scary. This is a div. The red lines are actually removed because it was using the old animator class. And the blue lines are actually added to have an animation. This source code is from the dictionary Plasma widget. And I'm going to show it actually running. Okay, I think we still have time. I'm sorry, I have 32 bits and a 64 bits build directory. Okay. I'm also running KDE trunk, so crashes might happen. Is the code changed? Yeah, okay. Okay, so I will remove this. Whoops. I told you guys. So if, for example, I add the dictionary widget, it was supposed to have an animation on the line edit. Are you guys able to see this animation on the line edit? No, because actually I'm not able to see it. Okay, I will run again just to show you guys. Okay, okay, okay. Now let's install the changed one. Okay. Let's, whoops, console. Qt, Plasma desktop. Is there a better way to reload the installed widget? Instead of killing Plasma desktop and restarting it? Okay. Okay, you should, in theory, be using the new widget, actually the same widget but with the new animation. I set it to have a duration of 1 second just to make it easier to actually see the animation. Okay, now we can actually see the line edit growing. By the way, the animation class, they are already being used on Plasma 4.4. For example, the zoom in effect of the plasmoid being inserted into the desktop is already using the zoom animation. As also when we delete the plasmoid, the zoom out animation is being used. And this nifty pulse effect, when you add the plasmoid, you have the plasmoid pulsing is already using the pulse animation. Okay? All right. So, yep. But say that you have another case. Say that you have a case, and this is the applet class on Plasma. The red lines were removed, blue lines were added. This is a more common case. Say that you have to perform something when the animation is over. How do you do that? Well, you have to connect the finished signal of the animation to your slot, the slot that is going to do something when the animation is over. Okay. So, yeah, 20 minutes. Woo-hoo. I have some special thanks. I would like to say thank you very much for KDE community as a whole, and especially for Plasma hackers, Errol Sego, our friend Marco, Igor, my friend, and Arthur. I think when I got started to this whole Plasma thing, there were 2 days in August where I was basically asking lots of questions to Arthur about the Plasma netbook stuff. But fortunately, it was just 2 days after that I started to ask questions to Errol and to Marco. I also would like to thank INDT in Nokia. INDT is like a Brazilian Nokia Research Center. It stands for Nokia Technology Institute. I work there. And finally, Camp KDE organizers, especially Jeff, because the event's been quite cool. Event staff are working hard to make everything to work smoothly. And I guess, actually I have a final demo. Here on this cell phone, I have that Plasma animations running on the cell phone. So if you guys want to have a look, please don't press the red button because it's going to terminate the application. Okay, questions? Oh, come on, guys. Oh, thanks.
Well, problem. Actually, I'm not sure I really got what this stack rotation thing was, or rotation stack, or
stacked rotation. Yeah. What?
Yeah. Well, I didn't really get what made it stacked, or what was the difference with the normal rotation.
Yeah, because actually you have a widget on one face, you have another widget in the behind. So this is why it's stacked.
That's a double stack. Okay, that's like a,
yeah.
That's how you call it.
So the idea is that, for example, say that you have a contact plasmoid. You have like a contact name and a list of contact names. So you could, for example, click on a contact and have another view with further detail. And this is a place where stacked rotation would be pretty cool. You know, instead of just a fade in or fade out, you could have stacked rotation.
Is there anything really Plasma specific about these animations?
What?
Or is there anything really Plasma specific about these animations, or is it just the cute graphics you?
Yeah. Actually, the animations, they only use a few Plasma specific bits. It's just trivial to make it a HAL Qt animation. As a matter of fact, what I have running on the cell phone is precisely that. It's a hair Qt animation. I think on my blog I posted about it, and I even made the source code available, how to use the animations in a context where you unfortunately don't have Plasma. Any more questions? Oh.
So this is in KDE 4.4 and KDE Legs,
yeah? Yeah, those animations, the question was if the animations are on KDE 4.4, yes, they are, and they are already being used.
Right, I can see those.
Yeah.
But it's in Qt 4.6.
Sorry?
Qt 4.6?
Yeah, Qt 4.6 is a requirement for KDE 4.4 as also for the animations. Oops, another question?
Yeah, regarding the you were mentioning that you have optimized it for also like small devices. I guess it's still all software based, right? So 100% software.
Yeah, it's software based, but say for example that you have a hardware accelerated device, you could for example use a Qt OpenGL graphics system, and everything would be hardware accelerated.
Yeah. But is that, do you have any specific code in there which is made to handle the situations better? Just that?
No, because I think it just makes sense to let this on the hands of the users also, being a responsibility of Qt.
Yes.
Our focus was on the memory footprint, memory allocations, and also code reuse, because actually the source code is pretty simple. If you have less lines of code, you are going to have something that is going to run faster, going to have less bugs. So.
Sure. Yeah, because you mentioned some of them work on the widget geometry directly, and some of them work on snapshots, like on pictures.
Yeah. Just to give you an example, the pulse effect. My first implementation of the pulse effect was a pretty stupid implementation, because what I was doing was actually create another copy of the whole widget, and then I did 3 transformations on it. I was doing an opacity transformation, geometry transformation, and a scale transformation. Yeah. But later, I think hey Marco, I think you gave the idea of not using geometry. Yeah. So later, Marco gave us the idea of just animating the scale and the opacity. So we cut off one of the parameters on the animation. And later, I implemented a way where we actually don't have anymore a copy of the whole widget, but what I have is a pixel map. So what I do is I have the widget, I create like a snapshot of it into the pixel map, and then I animate the pixel map.
So that's the only one pulse that works like that? Or the others work on geometry?
Well, that depends on the animation, actually. There are some things that you can't do without geometry. But for example, zoom in, zoom out, it operates on the scale, so it should run pretty fast.
The graphics user.
Yeah. Any more questions? We still have plenty of time. No? So, what?
Sounds really cool.
Yeah. I really love embedded device. So cool, to have your code running in the palm of your hand.
How is the comparison of performance on compositing versus non-compositing?
Sorry.
It's not really relevant.
What?
Compositing versus no compositing.
Composite versus no composite?
It's not really relevant because we are our canvas.
Yeah.
Okay.
Probably compositing would be a bit lower because the actual window would be direct off screen and then copied. But this is true for all applications.
I guess what I should say is on more powerful graphics hardware versus not so powerful.
Actually, you could, for example, run all the animations without hardware acceleration of any type. You can just use the raster graphics system. You are going to do everything on CPU, but it will just work.
Okay. Cool.
It really
Yeah.
depends on the quality of the.
But of course, if you have a uber power fucker graphics card, it's going to run even better.
The sort of set of 6 or so animations that you're showing off here, these are the only ones that have been actually implemented in KDE at this point, or is there plans to add a whole slew of different animations as well?
Yeah, well, I think at least this is my personal opinion for our roadmap, is do the difficult work of porting all the animations to the newer ones. But the idea is to provide more animations to KDE Libs users with time.
Okay.
Yeah. I bet. Oh yeah.
I was just wondering on YouTube Plasma programming, and I was just wondering if this work you've done is applicable to just regular KDE apps, or would you just go to regular So is it just like?
Those animations, they will only work if you have a QGraphics view based application, because we do the animations on QGraphic widgets. So, for example, Contact does not use the QGraphics view, so you can just use those animations. Actually, I think maybe there is a way to do that. Because if you have a Q object, as long as you have a property,
The exact same Q property
should work. Yeah, it should work. But we didn't design it. We didn't design it thinking about the more Q widget, traditional based applications. But yeah, actually, I think it should work. Yeah, it's an interesting idea.
Of course, anything that has to manage geometry from layout or something is not going to work, right?
How layouts and geometries play when you have animations? What was that the question?
Well, I guess, I mean, like if you're trying to animate, like make a widget grow when it's in layout, it's not going to work, right?
Oh yeah, okay. Actually, that demo that I showed and that is running on the cell phone, each QGraphics item is actually inside of a layout.
Oh.
But for example, it might be needed to explicitly notify the layout to recalculate the geometries. But it's quite easy to do that. You can just have a slot connected to the animation finished signal, and then you can just notify the layout object. But at least on my tests, it's working pretty well.
The QGraphics layout are not really rigid as a Q layout. So
Yeah.
you can just move items around until the layer doesn't calculate it, just the same one.
Yeah, Q fucking layouts. Yeah. Okay, any other question? Okay, so I think we are done. Thank you very much.